Hello, my name is Michael Nowak. I'll be doing my presentation on forced induction today. Get my screen filled in here. This is my audience. These are all my people. All right. What is forced induction? Forced induction is a technology which is used to compress air into engines' combustion chambers in order to improve air density, which in turn allows for more fuel and to be used, increasing horsepower, torque, and engine efficiency. This is typically achieved through external parts such as a turbocharger or a supercharger. On the topic of turbochargers, the turbochargers are a type of forced induction that rely on exhaust gases in order to spool up the turbine, which is connected to the impeller, which is where the outside air is sucked into the turbo and therefore compressed. Of course, this is a simple explanation, but this is also not an automotive class, so I don't have to go in depth with it. Since these run on the waste of an engine, they're considered to be an emissions equipment, and have no parasitic loss. They're using the waste from the exhaust gases to spool up. There are many different types of turbos, but both can run on the same principle of the original design. They differ in many ways. There's twin scroll, variable geometry, and this is more just changing the design of the actual impeller, expeller. The invention of the modern turbocharger revolutionized emissions and economy. According to Mobile One and supercharger versus turbochargers, how they work, it is explained that turbos allow smaller engines to make similar power to their larger counterparts by forcing more air into the cylinder, making them much more efficient, which therefore reduces their emissions and increases horsepower. The idea is if you can have a large vehicle, say for example an Expedition, you can put a much smaller turbocharged engine as compared to a much larger naturally aspirated engine. It is also used in the world of racing. Adding more boost and adding more fuel will create a lot more horsepower. Very popular in hot rodding. It's a good example of how to add more power without taking anything away from the engine. The only kind of problem they have is they have what's called lag. Since it runs on exhaust gases, it takes time to spool up that turbo. The exhaust needs to reach a certain pressure to actually start building boost. So that's one of their more unfortunate drawbacks. Superchargers can be made in different forms. The most common are twin screw, root style, and centrifugal style. Twin screw works more on like turning around each other blades, and there's two parallel screws inside of a big box, and roots is like fins that just kind of go into each other. A centrifugal style is like a turbocharger, but it's belt driven, so it's just a compressor wheel and a turbine housing, and it's driven by the crank. Root style and twin screw style superchargers both function on the same basic principles. They use two spinning shafts with fins to compress air into the engine. These are typically belt driven, which, like I was talking about earlier, how a turbocharger doesn't have any loss. A supercharger has a parasitic loss because it's directly connected to the crankshaft. The crankshaft now has to turn for not just the weight of all the accessories on the engine, but now the supercharger as well. It has to turn those blades. According to Car and Driver and turbochargers versus superchargers, it is explained that the supercharger is directly attached to the crankshaft via the belt, which delivers much more instant boost as the RPM of the engine increases, which allows for much linear power increase as compared to the ramp up of a turbo. And I think that's what draws a lot of people in the performance side of things to a supercharger rather than economy. You don't really see superchargers on factory vehicles anymore unless they're a performance trim. There was a time and place where it was used for almost the same idea. They believed that by adding more displacement, that they could force more air into it and have a more efficient engine. Turns out they just keep making them fast, so it didn't really work out. The supercharger delivers instant power. Since it's attached to the crankshaft, the minute you hit the throttle, you have boost. This revolutionized the performance industry, with the first superchargers being used for racing as early as 1908. It spent the vehicle that is the example for this in the picture in the top right set a bunch of early speed records and won the Great Despair Hill Climb, which was a huge deal at its time. People didn't really believe in the technology, so conclusion. Both turbochargers and superchargers are revolutionary pieces of technology, have lots of accolades in both of their respective categories of racing, everyday driving. Both force air into an engine to create more horsepower and increase engine efficiency, but are entirely different systems with very different uses. Question to leave off on would be which is better. Pictured in the top right, actually, I have what's known as a twin-charged engine. Typically, it's either one or the other. Some companies like Volvo have pushed the manufacturing mark here and have created what's called a twin-charged engine, where the supercharger that's attached to the crankshaft feeds the turbocharger. So instead of having lag for that turbocharger, the supercharger is pushing boost into the turbo, which is also running off the exhaust gases. So it gets a lot at once and allows it to spool up really quickly, and those cars make a lot of power. They're very, very quick. Very, very fuel inefficient, unfortunately, as you can imagine. Thank you for listening. These are my sources. Whitson G. Wrote Turbochargers versus Superchargers from Car and Driver. And then the Mobile One engineering team wrote Superchargers versus Turbochargers and how they work. Is there any questions I can answer? No? Alrighty. Wonderful. Thank you guys. I appreciate it so much.